Hi, welcome to another collision video.
In the past, cars were primarily mechanical. You hit the gas pedal and it would just put more fuel in the engine. Nowadays, it's all electronic. So when you hit the gas pedal, it sends a signal saying the user, the human, would like to add some fuel, and the computer decides if it's going to do it or not. In the past, you'd have door locks that when you pressed to unlock all the vehicle doors, there was a wire that went from that button to every single door. For each new component you add, you'd have to add more wires for everything it wants to talk to. This can be a lot of wires, it can add a lot of weight and a lot of cost to a vehicle network. To reduce this, auto manufacturers came up with a bus network. This bus network is basically a network that runs through the middle of the car, and all the components that need to talk on that bus attach to this bus. This greatly reduces the amount of wiring and cabling you need for a vehicle, which cuts down costs and even weight, which improves fuel efficiency. There are several different types of buses your vehicle will have, and they vary based on the type of vehicle and the features that are required by your vehicle. Some of these networks are LIN, K-Line, KWP, CAN, MOST, and FlexRay. Which bus your vehicle is using often depends on the cost and what the functionality of that bus is for. One of the new entries you have is Ethernet. Ethernet is the same kind of Ethernet you would have in an office environment where you have your computers connected to each other. Except in the automotive field, it's a little more ruggedized. It uses only 4 wires to connect everything to each other as opposed to 8 that you would typically have in an office environment.
The automotive industry is facing a sea change in new applications, things like self-driving cars, advanced driver assistance, all sorts of exciting ways to interact with the car and to use the car are driving a new approach to the electronics and the data in the vehicle. The common theme of all of these different technologies, all of these different opportunities is bandwidth. So in the past, there were purpose-built automotive-specific applications that sent very small amounts of data, maybe in the kilobit per second range. But now we're talking about existing systems with 100 megabits per second and gigabit, and very quickly moving to 2.5 and 10 gig. The industry needs a way to be able to bring this into the car and provide the flexibility to solve not just these self-driving car or the existing problems, but also the future things that we don't even know of today. Ethernet is a technology that has a lot of experience and has been deployed in many places. And we know it as the blue cable that you plug into your laptop, and it's also the backbone of the internet and all sorts of data communications today. And that's why the industry has taken it for automotive. But on its own, it's not enough, because when you're in the vehicle, you have to deal with the robustness and the temperature that are required by physically being in a vehicle. And now you have to deal with data that's real time. As the bandwidth grows, Ethernet was also growing to match that. And we are developing the systems to make that happen. We have to take the existing Ethernet and develop versions of it specifically for automotive. And that happens in 2 ways. One way is on the physical side, where we improve the robustness with things like a 2-wire interface and specialized automotive connectors. And the other way is on the delivery, where we now take protocols that were originally developed for industrial applications, bring them into automotive, and this is things like the time-sensitive networking, or TSN, that allows you to have real-time data over an Ethernet network. You might ask, why Ethernet? Why not use a proprietary technology? Why not continue with the older approach? Well, the architects have a big challenge. They're designing a system that they will spec out today, they'll build in 3 to 5 years. That system is now in production for new vehicles for 7 years after that, and they won't know what people need in the car. A real-life example of this is a system that had a forward camera looking for street signs to read the speed, to be able to provide that information up on the dashboard. After the car was released, they realized that they can use this same camera, look at the condition of the road, and change the ride of the vehicle to improve the performance. Here's an example where they were able to improve the car, make a big difference, but no changes to the hardware, no changes to the fundamental approach to sending the data in the vehicle. And this is the sort of future-proofing that is driving the adoption of Ethernet today. How do we make this work not just technically, but make it work in a way that they can deploy across their entire fleet? And that means quality, that means reliability, that means the right cost points. And to do this, we have to go beyond just the existing technology and really drive it through the standards. And that's a focus that we have, is developing these higher speed standards on the physical layer with the 1 gig, 2.5 gig, and 10 gig in Ethernet, and also on the protocol side, improving the standards to provide automotive-specific solutions.
Modern cars are packed with electronic systems that constantly collect all kinds of information about the on-the-go journey. Analyzing this data can open huge business possibilities, and artificial intelligence is best at that. Here's how data can become a source of business. Artificial intelligence can collect telemetry data from the user's car and predict breakdowns or schedule the next maintenance visit. AI can analyze the user's lifestyle, places he goes to, the roads he drives, the driving behavior, and so on. Based on this analysis, AI can make personalized offers with additional features or accessories. And this is not all. Artificial intelligence allows targeting offers precisely to specific users, bringing clients back to a dealer's network and reducing the number of breakdowns due to timely maintenance.
Putting that together, and now the car manufacturer has a solution to make the next generation, and as a leader in developing automotive semiconductors, this is a critical focus for us.
Thank you for watching. Collision TV signing off.